Good evening, students. Today we have come again with new topic, that is data structures. Uh, this is the last topic of Python programming. Okay, and this is chapter 9 for class 12 Computer Science, CBSE Code number 083. Okay, why it is chapter 9? Last chapter we have learned, that is chapter number 5, and this is chapter number 9 because the chapter number 6, 7 and 8 have been removed from this new syllabus for this session. Okay, so we have come to this chapter number 9. Okay, now first of all we will learn what is a data structure. Data structure are considered as a way of organizing and storing data in such a manner so that it can be accessed and work over it can be done efficiently and less resources are required. Okay, data structures are considered as a way of organizing and storing data. First of all, data structure is just a way to store data, and that data must be stored in an organized manner. Organized manner means each and every data must be stored in that manner that it can be accessed, or it can be modified, it can be changed, it can be read or displayed with an easy manner, with efficiently, with less number of resources required to do all this work. For that purpose, data structures is created, is developed. Okay. It defines the relationship between the data and the operations over those data. Actually, what happened? We have to do lots of work on data. Data are the basic part of any organization these days. With these data, they can make future plannings. They can understand the current scenario. These things they can understand. So data are very much crucial. So there must be a facility, there must be a way to store this data in such a manner that less resources is required and more of the work can be acquired, can be done. Okay, for that purpose data structure is developed here. Okay, so there are many types of data structure defined that make it easier for the computer programmer to concentrate on the main problem rather than getting lost in the details of the data description and access. Okay, data structures are already defined. So many types of data structures are already defined, so we need not to again make any new data structure or develop any new data structure, develop any new way to store data and access data. Okay, these are already developed, thus we have to use those techniques. Okay, and mainly concentrate on the main problems of the data, or main operations of the data, what operations we have to do with that data. Okay, in short, a data structure is named group of data of different data types which is stored in a specific way and can be considered as a single unit. Okay, if same data, if so many data are to be stored, okay, as a single unit means whenever we want those data, each and every data will come at the same time. So these data are stored as a single unit. Okay, stored in a single unit, and it has given a name. Group of data is given a name. Okay, and different data types means we can store integers, floats, doubles, to boolean type, string type, tuple type. So many types of data can be stored in a single unit. Okay, a data structure has well-defined operations, behavior and properties. Okay, whatever the data there are so many data types, so many data structures are available. Okay, so which one we will choose for our work, for storing our data. then in that data structures operations are already predefined, that these operations can be done on this type of data structure. These are the behavior of that data structure, these are the properties of the data structure is already defined. So we have to select from all the data structures for our data to store in that data structure. Okay, different data structures here. Data structures allows users to combine different data types in a group and also allow to process the group as a single unit. Means we can store so many types of different data types, okay, of data in a data structure, okay, and these data structures can be grouped, okay, and this group can work as a single unit. Then what it help us, if we do like this, then it makes things much simpler and easier to work, very much simpler and easier. We will see these things in our practicals. Okay, we will learn these structures in detail. Okay, we will write programs also. It is of two types simple data structures and compound data structure. Simple data structures and compound data structure. Simple data, these are normally built from primitive data types like integers, float, characters and booleans, for example arrays or lists. Okay, simple data structures are built normally with the primitive data type. Primitive data type means integers, means numbers, okay, floating point numbers or some numbers, characters means strings, name, okay, address, we can take booleans, true or false or yes or no, this type of value, 0 or 1 value, means simple values we have to take. Okay, this and the simple data structures are names as arrays or list we already know, list we have learned. Okay, and in this chapter we are using mostly we are using list. Now second one is compound data structure. Compound data structure is combination of various data types structure to make more complex structure. Suppose we want to store more complex data, so many data, then that time we need compound data structure. It is also classified in two types. What are those types? Linear data structure and then non-linear data structure. Okay, linear data structure, these are single level data structures such as stack, queue and linked list. Stack, queue and linked list are known as linear data structure, means single level data structure. There is only one level of data it can handle, it can store. Non-linear data structure, these are multi-level data structures such as trees. We will see examples later. Okay, see different types of data structures as we have discussed in the previous slide, that so many data, there are two types of data structure, simple and compound data structure. We will see in a pictorial way. See, in a pictorial way, data structure, there are two types of data, simple data structure and compound data structure. Then in simple data structure we will learn only arrays or list. Okay, but at the same time Python offers many linear data structures other than list, tuples, sets and dictionary, which we already learned these things in our previous classes. Okay, now other type of compound data structure, there are two types of data structure, linear and non-linear. Linear data structure is, say for example, stack, queue and linked list are the linear data structure, and non-linear data structure is known as trees. Okay, arrays or list. Arrays or lists are same thing. Previously lists are called arrays, and when we are learning Python language, these arrays are known as lists. So list refers to a named list of finite number of similar data elements. Okay, arrays or lists are refers to as a named list of a finite number of similar data elements. See, similar data elements, it means we have to store same type of data in each and every place. Each of the data elements can be referenced by numbers, like 0, 1, 2, 3. Okay, index number, we know that index number is there, and in Python negative indexing number system is also there. If the name of array is if the name of array, a list of 10 element is A, capital A, okay, then its elements can be referenced as A0. We all know A1, A2, A3, A4, A5, like this up to A9. Okay, and from 0 to 9, total 10 elements is available here. Arrays or list can be of one, two, or multi-dimensional. Arrays can be also multi-dimensional. Okay, see how we store data in a list in Python language. Suppose a list having length 5 and each cell containing one character, PROBE. Okay, 5 characters are there. Then what happened? Index number of first cell will be given to 0, then 1, then 2, then 3, and last will be given 4. Similarly, negative indexing is also given in a list. That is, the last element will be given as -1, then -2, -3, -4, -5. In any way, we can recall these data one by one by using any of the index, positive index or using the negative index. Whichever we will want, we can access any element using any of the index system. This is the list. And throughout this chapter, we will use list to do or to work with data structure. Next one is stack. These data structures store access and list. These data structures store and access list of elements in LIFO. LIFO means last in, first out technique. Okay, in a stack, insertion and deletion takes place only at one end. In a stack, insertion and deletion takes place only one end, called the top. Let's understand what is a stack. Suppose we have a stack of books. Okay, see, and if we want to put a new book, then where we have to put? We have to put on top of that stack. Then, okay, if we want to take or remove any of the book, then in a stack we should take from the top of the box. Okay, see here the example. This is the empty stack, and one element is going to be stored. This addition of the element is known as push operation. And again we have added second element. Okay, and if we want to take any one element from the stack, then only the top element we can remove or we can take. And this taking or removing an element from a stack is known as pop operation. Okay, this is known as stack. This is a structure, data structure, and here we can do some operation. First operation is known as insertion and second operation is known as deletion. Insertion is also termed as push operation and deletion is also known as pop operation. And both these operations can be done only from the top of the stack. Okay, that's why it is known as LIFO technique. Last in, first out. If we put the element, whatever the element we put in the last, that if we want to take that element, then the last element we remove or it will be taken. That's why it is LIFO stack. Now here An example, Q is also a data structure. These data structures store and access list of elements in FIFO technique. FIFO means first in, first out. Okay, whoever comes first, service will be given to that person, that first person. Okay. In Q, insertion takes place at the rear end, but here what happened? Insertion means addition of an element comes to the rear position, means last position at the end of the queue. We can add any new element at the end of the queue, and deletion takes place at the front of the queue. You can take example of this. Suppose here some services she is providing, okay, then she will provide service for the first person, whoever come the first. That's why it is known as FIFO, first in, first out. Okay, and suppose a new person came, then what, where he will come, he will come at the rear of the queue. This position is known as rear and this position is known as front. Okay, see the example here. Okay. Mhm. The back side, this is the back side and this is the front side. And if we want to remove or if we want to process some element, then we have to process the front elements. And if we want to add new element, then at the back side of the queue we can add. This technique is known as queue technique, and addition is known as NQ and deletion is known as DQ. Okay, real question. What is this FIFO technique? It uses FIFO techniques. Insertion is done at the rear place and deletion is done at the front place. Okay, say for example, queue of people to cast their votes. Linked list. It is also a type of list, but it is known as linked list. Linked list are a special list of some data elements linked to one another. Linked lists are a special list of some data elements linked to one another. In linked list, each elements are linked to one another by having each element pointing to the next element. Means what happened in a list, elements are not stored in contiguous manner. Contiguous manner means one after another like this, one by one. It is not stored like this. But instead, what it does, it creates a node. See example here. It creates a node, means whatever element we have to store, that element is stored at a place in the memory or anywhere in the computer, that is in the place it is stored, that single number, and that single number is known as node. Okay, and it doesn't need that the next element or the previous element must be at the adjacent of that node. Okay, it doesn't require in this linked list. Okay, any element can be stored anywhere in the memory. Okay, anywhere in the memory, and then what it does, it links one element to the other element by accessing the address of that element where the element is stored. Okay, where the element is stored. See here, all the elements 10, 20, 30, 40 is stored anywhere in the memory. It is not stored contiguously, it is stored randomly at any places. So 10 is stored somewhere, 20 is stored somewhere, 30 is stored somewhere. How they are linked with one another, and if we read elements, these elements, all the elements, then it will display sequentially. It will display sequentially, it will work sequentially. There is no problem in accessing these elements. but it is linked with each one using the pointer or using the address of the element, of the address of the next element. Okay, it means that first element contains the address of the next element. Okay, that's why both are linked with one another. The second element contains the link of the third element, and third element contains the link of the fourth element. If there is no more element, then fourth element will not contain any address. Okay, that is termed as null element. Null means there is no more element in the list. So each element contains address of the next element. Okay, that address is also termed as pointer. Okay, or the link. It is also termed as a link. That's why this type of list, this type of arrangement of the elements is known as linked list. Okay, there are two parts. Each and every node is having two part. Okay, each and every element having the two part. That first part is known as info part and second part is known as pointer part. That's why it is displayed in two color. One, each node is displayed in two color. The blue color stores the element and the green color is known as the pointer, and it stores the link of the next element. Okay, the info part stores the information and the pointer part stores the next element, points to the next element in the list. Okay, so that's why it is linked list, and this is a special type of linked list. Hmm? Now trees. Trees are multi-level data structure having a hierarchical relationship among its elements called nodes. We know that trees, there are two types of data structure. First is simple data structure, second one is compound data structure, and within compound data structure there are again two categories. First is linear data structure, second is non-linear data structure. In non-linear data structure, that is multi-level, more than one level is there, and trees belongs to that category. See, trees are multi-level data structures having a hierarchical relationship among its elements called nodes. Hierarchical means, what is the term hierarchical? Hierarchical means there is a relationship between one element to another element. Say for example, uh, parents means father or mother is having one child. Okay, then the child is having their parent, okay, their higher level. That's why it is known as hierarchical. Okay, in any organization there is also a hierarchy. Say for example, in our school, in our GNV, there is a hierarchy of employees. There is a principal, and under principal there is so many employees, office employees and the teaching employees and non-teaching employees. Okay, teaching employees, there is a PGTs, TGTs, and also some lab attendants, and so many teachers are there. Okay, in the office, this type of structure is known as hierarchical. Okay, so to deal with that type of data, this tree is very much helpful. This tree type of data structure is very much helpful. Okay, tree are multi-level data having hierarchical relationship among the elements called nodes. Each element is known as nodes. Topmost node is called the root. Okay, this is topmost is called the root, and bottommost nodes are called the leaves. Just of the tree, just like a tree, but here tree is upside down. Okay, tree is this tree is displayed as upside down. Okay, so that picture is given like this. You can see the picture. Okay, it is tree. Here is the root. Okay, top is the root, and then branches is there and leaves are there. Similarly, this tree is arranged like this. This is known as the root element, and here the branches element. And then these are the leaves. Terms are leaves. Okay, in this, according to this, data is arranged in a tree data structure. Each node in the tree have pointers pointing to the next node below it. Okay. Pointers. Trees also contains pointers or the links, okay, between the nodes. This is the tree. Now, we have learned so many types of data structure. We can, depending on our data, which type of data we are having, we have to select one of the data structure to store or to work with that data. Okay, judicially we have to select one data structure depending on the data, whatever the data we have available. Okay, so data structure, some operation, what operations we can do on data structure. See, the basic operations that are performed in data structures are insertion. We can insert, adding a new element is known as insertion. Then deletion, removal of the element is known as deletion. Okay, then searching we can do, we can search some element in the data. Traversal we can do. Traversal means processing all the data or displaying all the data, that is known as traversal. Sorting means arranging data in an arranged order, in an ascending or descending order. Merging of data, suppose there are two or more data structures. Okay, data are not merged, data are prepared by different type of persons, then all data collected, and then merging processes means to combine all the data in a single data structure. Okay, combining elements of two or more similar data structure to form a new structure of the same type. Okay, these operations we can do on a data structure. Okay, now, now that's all folks. Thanks. Have a nice life.